Once data is stored, verification begins automatically. The mechanism that does this is PDP, or Proof of Data Possession. Let's get into it. To understand how PDP works, we start with how data itself is represented. In the previous module, we talked about the PCID. This happens when your uploaded file is broken into fixed-size chunks within a Merkle tree. Each chunk becomes a leaf node in a binary Merkle tree. Those leaf nodes are hashed, then paired and hashed again. This process repeats layer by layer until there is a single hash at the top of the tree. That top hash is the Merkle root. In Filecoin Onchain Cloud, this root is called the PCID. The PCID is a cryptographic commitment to the entire file. Every byte of the original data contributes to that value. If any part of the data changes, even by a single bit, the PCID changes. This structure makes verification efficient. That top hash is the Merkle root. In Filecoin Onchain Cloud, this root is called the PCID. The PCID is a cryptographic commitment to the entire file. Every byte of the original data contributes to that value. If any part of the data changes, even by just a little bit, the PCID changes as well. This structure makes verification efficient. So each provider does not need to send the entire file back to prove that they have it. Instead, they prove possession of specific parts of the Merkle tree. For each proof, the provider submits a small set of hashes that form a path from selected leaf nodes up to the known root. If those paths recompute to the registered PCID, the proof is valid. Those paths can only be generated if the provider actually has the underlying data. There is no shortcut. Once the data is deleted or corrupted, the math no longer works. Once the data is registered, the PDP verifier contract knows two things. It knows the PCID that defines the data, and it knows which provider has claimed responsibility for storing it. From that point on, the provider is accountable. Once again, at regular intervals, the verifier contract issues challenges. These challenges are derived from decentralized randomness using the DRAM beacon, which makes them unpredictable. Each challenge specifies which positions in the Merkle tree must be proven for that time window, and the provider has a fixed amount of time to respond. If the provider has the data, responding is straightforward. They look up the challenged positions in their local copy, generate the corresponding Merkle path, and submit the proof on chain. The verifier contract checks the proof against the registered PCID, and if the math checks out, the proof is accepted and recorded for that period. If it does not, that proof fails. Verification feeds directly into payments, and only time periods that were successfully proven are eligible for settlement. If a provider misses a proof window or submits an invalid proof, payment does not occur for that period. When you upload files to Filecoin Onchain Cloud, you do not just get back a collection of PCIDs. These pieces are grouped into a structure called a dataset. When a dataset is created, three things are tied together. First, the PCIDs are registered with the PDP verifier contract, which means those files are now subject to continuous proof requirements. Second, a payment rail is created in Filecoin Pay. This is a dedicated payment channel between your account and the provider for that specific group of files. As proofs succeed, funds flow through this rail automatically. Third, metadata is attached. So metadata is information about your data. Labels, tags, and context that help you understand what a file is and how it should be used. In Filecoin Onchain Cloud, metadata is written on-chain alongside the storage and proof records. It does not live in a provider's private database. It is permanent, transparent, and verifiable, and stored on the Filecoin virtual machine on Filecoin. The blockchain now holds cryptographic proof that your data exists, the rules under which it is stored, and the context you attach to it. No single provider can alter it. No off-chain database needs to stay alive for the information to remain valid. This becomes especially important when storage requirements diverge. If different files need different providers, different performance layers, like CDN delivery or regular delivery, or different compliance constraints, they belong in different datasets. The right mental model is to think of datasets as storage agreements, not directories. Group files that share the same provider, payment terms, and proof obligations, and separate files that need different terms. Taken together, this is what makes verification practical at scale.